Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. In this video, we are going to discuss with the new chapter, it is the Nephelometry and turbidimetry. In previous video, we have finished with the atomic absorption spectroscopy. If you have not watched my previous videos, you can watch my previous videos by subscribing to my YouTube channel. And if you like the content of this YouTube channel, then you can share with your friends. Now let's begin with our today's session, that is the nephelometry and turbidimetry. In this video, we are going to discuss about the introductory part as well as the difference between the nephelometry and turbidimetry, then instrumentation of turbidometer, as well as different factors that are affecting the nephelometry and the turbidimetry. So let's begin with our today's session. Before starting with this session, just we will see what are the learning outcomes of this session. After this session, students will be able to explain theory, instrumentation and the factors affecting the nephelometry as well as the turbidimetry. Together, both the instruments are known as the nepheloturbidimeter. Now, what is the meaning of nephelometry and turbidimetry? Nephelometry and turbidimetry, these are the techniques of analysis that are closely related to colorimetry. Much of the theory and the equipment that is used in colorimetry is applicable to the both nephelometry as well as the turbidimetry with the slight modification. Both nephelometry and turbidometry are based upon the scattering of light by non-transparent particles which are suspended in the solution. Means both the techniques are related to scattering of light. This scattering of light is taking place because of the particles, suspended particles that are present in the solution. For example, suspension. And these particles are non-transparent towards the light, and due to which these different scattering effects are produced. Now, one question may arise in your mind that what is the meaning of scattering? Yes, I will tell you what is the meaning of scattering. However, these two techniques differ only manner of measuring the radiation. Though both the techniques are dependent upon the scattering of light, these techniques differ in the manner of the measurement of radiation. When the electromagnetic radiation or the light or energy strikes on the particles that are present in the solution. Now, whatever the spectroscopy techniques like UV spectroscopy, visible spectroscopy, atomic absorption spectroscopy, these techniques that we have studied, they are applied to the homogeneous solution where whatever the solid molecules are there, the solid molecules are present in the dissolved form. But in case of nephelometry as well as the turbidimetry, our solute, that is they are not in the dissolved form. They are not part of the homogeneous solution. Heterogeneous solution like suspension are present. And if they are present, then that can be analyzed by using the nephelometry as well as the turbidimetry. So in such a case, when electromagnetic radiation falls on particles that are present in the solution, some of the light will be absorbed by the particle, some of the light will be transmitted through the solution as such, some of the light will be either reflected or some of the light will be scattered. Now, amount of light scattered is proportional to the concentration of insoluble particles. So, this effect is commonly known as the Tyndall effect. Light scattering effect is known as the Tyndall effect because this is the name of the scientist who has proposed this particular effect. Means when our solution is consisting of insoluble particles and when light is passed through our sample solution, what happens? Due to the presence of the insoluble particles, whatever the light that is falling on these insoluble particles, it will be scattered, and this phenomenon is known as the Tyndall effect. Now just I will show you how these different effects, that is the absorption, reflection, scattering as well as the transmittance will occur. Suppose this is our sample solution which is consisting of the number of particles. Now as it is a heterogeneous solution, you can consider that the particles are present in the insoluble form. Now suppose if a light is fall on the surface of this particular sample solution, part of the light will be reflected in a such a way that then part of the light will be transmitted, means the amount of light that is falling, it will not be absorbed, it will not be reflected, and as it is not absorbed, it will pass as such through our sample solution. Then also part of the light is absorbed, means the solid molecules that are present, they will absorb the some amount of light, and part of the light may be scattered, means deviation in the angle of the incident light will takes place, which is known as the scattering. While in case of transmittance, you can see the whatever the light that is falling, it will transmit as such. But here the angle of incident light will be changed. This phenomenon is known as the scattering. Now if our solution is consisting of the more number of undissolved particles or insoluble particles, like say for example this, if these insoluble particles that are present which are not transparent to the light, then the scattering effect is more, means the light will be scattered in n number of direction. So this effect is known as the scattering, and nephelometer as well as the turbidimeter is based upon the measurement of light that is scattered. The only difference between the nephelometry as well as the turbidimetry is that the light, that is measurement of light, the way by which we are going to measure the scattered light is different. Now we will see what is the meaning of turbidimetry. When light is allowed to pass through a suspension, the part of the incident radiant energy, that is the light, is dissipated by absorption, reflection and refraction, while the remainder is transmitted. Measurement of intensity of transmitted light as a function of the concentration of the suspended particles forms the basis of turbidimetric analysis. Means amount of transmitted light is measured in terms of the concentration. If the concentration of that particular suspended particles is more, then this particular turbidimetry is used. Then what is the meaning of nephelometry? In nephelometry, the light is allowed to pass directly through the sample solution which are having the suspended particles. The amount of radiation scattered by particles is measured at an angle of 90 degrees Celsius to the incident beam. So this is the major difference between the nephelometry and the turbidimetry. In nephelometry, we are going to measure the radiations at 90 degrees Celsius to the incident beam. This detector is placed at the 90 degrees Celsius. While in case of turbidimetry, as such our light will pass directly and the measurement is done at, you can say, 180 degrees Celsius. So this is the basic difference between the nephelometry as well as the turbidimetry. The measurement of intensity of the scattered light as a function of the concentration. Here the measurement of scattered light is carried out as a function of concentration of the dispersed phase, or you can say suspension, forms the basis of nephelometric analysis. So this is the major difference between the nephelometry as well as the turbidimetry. Now turbidimetry and colorimetry, these are the quite similar techniques. How they are similar? Turbidimetry is much similar to the colorimetry because both these techniques involve the measurement of intensity of light that is transmitted through the medium. That's why both the techniques are quite similar. That's why if a certain modifications are done in a colorimetric instrument, we can use it for the turbidimetry measurement. Remember, colorimetry is used for the homogeneous solution, means solid particles are in dissolved condition, while in turbidimetry it is used to measure our heterogeneous solution like the suspension. Then But these differ in the sense that the light intensity is decreased by the turbidimeter, and in case of colorimetry, light intensity is decreased by the absorption in the colorimeter. So this is the basic difference between the turbidimetry and the colorimetry. Then nephelometry and fluorimetry, these both the techniques are quite related to each other. Nephelometry is much similar to the fluorimetric method because both involve the measurement of scattered light. But the basic difference is that scattering is elastic in fluorimetry while it is inelastic in the nephelometry. So this is the difference between the nephelometry and the fluorimetry. So this is about the introductory part about the nephelometry as well as the turbidimetry. It means that both the incident and the scattered light are of the same wavelength in nephelometry, whereas scattered light measured in the fluorimetry is of the longer wavelength than the incident light. So this is the basic difference between the nephelometry as well as the fluorimetry. Now after this we will see what is the actual theory involved in the nephelometry as well as the turbidimetry, that is the reflection versus the scattering. Both the reflection and scattering phenomena are very important in turbidimetry as well as the nephelometry. If light is allowed to pass through a solution which is having a suspended particles, then reflection will take place if the dimension of suspended particles are larger than the wavelength of the incident light. Means this is the also another basis by which this turbidimetry and the nephelometry will be taking place. Because reflection and scattering, which phenomenon will occur, it largely depends upon the size of the particles that are present. Means if a light is allowed to pass through a solution which are having suspended particles, reflection will take place when the suspended particles are having the larger as compared to the wavelength of the incident light. If the particles are having larger dimensions as compared to the wavelength of the incident light, then reflection will occur. On the other hand, the scattering will take place if the dimensions of suspended particles are of the same order of magnitude or they are smaller as compared to the incident wavelength. In that case, scattering will occur. And this distinction plays an important role in the nephelometry and turbidimetry because it affects the sensitivity of the measurement as well as how the measurement is made. So this is the basic difference between the scattering as well as the reflection as well as it will takes us the different techniques, that is nephelometry as well as the turbidimetry. In nephelometric measurements, the suspended particles should be small with respect to the wavelength that is used, and this is required so that scattering rather than the reflection predominates. In the nephelometric, what we are going to do, the suspended particle should be small with respect to the wavelength that is used, and this is required so that the scattering will predominate as compared to the reflection. At the same time, smaller particles undergo scattering to give rise a symmetrical pattern of secondary rays in a space with a maximum intensity of the 90 to the primary incident, and that's why most of the instruments used in nephelometry involve the measurement at the 90 degrees Celsius. So the reflection or the scattering which effect will predominate, it will largely depend upon the particle size. If small particles are there, then the scattering will occur, which is also shows a Tyndall effect, and at that time we can use the nephelometry. Remember, when scattering effect is occurring, we are going to carry out the measuring of the intensity at the 90 degrees Celsius. So this is about the nephelometry. In next part, we will discuss about our turbidimetry principle. Thank you.